Question 1. Solve 7x minus 27 is less than 8. As I'm solving for the letter x, my first step is to move the negative 27 to the other side, in this case to the right, by doing the opposite. Opposite minus 27 is to add 27 to both sides. On the left-hand side, I'm left at simply 7x. As I know, negative 27, add 27 will cancel. You keep the inequality sign facing the same direction, so it's going to be less than. 8 add 27 on the right gives us 35. I don't want 7x. 7x in algebra means 7 multiplied by x. The opposite of multiplied by 7 is to divide both sides of my equation by 7. 7 over 7 will cancel to leave us with single x. Keep the inequality sign, so less than. 35 divided by 7 gives us 5. Question 2. Write 124 as a product of its prime factors. Well, I know my prime numbers. My first prime number is 2. It's the only even prime number. My next prime number is 3, 5, 7, etc. Starting with my number 124, as it's even, I know that 2 is a factor. So therefore 2 divides into 124, 62 times. If it's prime, we put a ring around it. Again, 62 is even, so I know 2 divided into 62, in this case 31 times. And 31 is prime, so I put a ring around it. The word product means to multiply. So all the numbers I put a ring around, I now multiply between them. So 2 times 31. Question 3. A delivery company has a total of 160 cars of vans. The number of cars in the ratio of number of vans is in the ratio of 3 to 7. As I was given the total number of cars and vans, my first step is to add up the number of parts. In this case, 3 add 7 gives us 10. Therefore, to work out one part, I divide the total number of vehicles, which in this case we know is 160, by the number of parts, which in this case is 10. And 160 divided by 10 gives us 16. I know 1/8 of the cars use electricity, 25% of the cars use diesel, and the rest of the cars use petrol. And I'm asked to work out the number of cars that use petrol. As I'm only interested in cars, therefore looking at my ratio, I can see the number of cars has 3 parts. So therefore I'm going to work out the total number of cars. So as cars have 3 parts, I know each part is worth 16. Therefore the number of cars is going to be 3 times 1 part, which is 16. And 3 times 16 gives us 48. I know 1/8 of the cars use electricity. And of in mathematics means to multiply. So therefore it's going to be 1/8 of the total number of cars, which we know in this case was 48. When calculating a fractional amount on a non-calculate paper, we always divide by the bottom and multiply by the top. In this case, 48 divided by 8 is 6, and 6 times 1 is simply 6. So therefore 6 cars use electricity. I know that 25% of the cars use diesel, and again, of in mathematics means to multiply. 25% as a fraction is quarter. So I've got a quarter multiplied by the number of cars, which again is 48. Again, when calculating a fractional amount, we always divide by the bottom and times by the top. Well, 48 divided by 4 gives us 12, and 12 times 1 gives us 12. So therefore 12 cars are diesel. As I'm told the rest of the cars use petrol, well, I know 6 of the cars use electricity, so 6. Add up the number of cars that use diesel, in this case 12. Well, 6 add 12 gives us 18. In total, there was 48 cars. So the rest of the cars must use petrol. So therefore 48, subtract the 18, and that will give us 30. So therefore 30 cars use petrol. Question 4a. Write 1.63 multiplied by 10 to the power negative 3 as an ordinary number. An ordinary number is removing this powers of 10. If you've got a negative power of 10, instead of multiplying by 10 that number of times, a negative power of 10 is the same as dividing by 10 that number of times. So as we've got negative 3, that's the same as dividing by 10 3 times. Hence, 1.63 divided by 10 3 times will get us 0.00163. Part B, we're asked to write 438,000 in standard form. Standard form is always a number between 1 and less than 10, and it's always multiplied by a power of 10. If there's no decimal point in our original number, we know it's at the end, because this is 438,000. We know our value for A has to be between 1 and less than 10. So we're going to place our new decimal point after the first non-zero digit from the left. The first non-zero digit from the left is the 4. So my new decimal point goes after 4, in between the 4 and the 3. So therefore my number term, I must copy all the digits until it gets to zeros. So my value for A in this case is going to be 4.38. As soon as it gets all to zeros, I don't need to copy it. We know it's then multiplied by a power of 10. So it's going to be multiplied by a power of 10. To find our power, all we simply do is count how many places have I moved my decimal point. Well, originally it was at the end, and it's now in between the 4 and the 3. So it's moved once, twice, 3, 4, 5 times. So therefore it's 4.38 times 10 to the power 5. Part C, we're asked to work out 4 times 10 squared, multiplied by 6 times 10 to the power negative 5, and to give our answer in standard form. When multiplying numbers in standard form, our first step is to multiply numbers in front. So 4 times 6 gives us 24. Looking at our powers of 10, here I have 10 to the power 3, multiplied by 10 to the power negative 5. Applying our laws of indices, if we're multiplying and we've got the same base, we keep the base the same, in this case 10, and multiplying means we add the powers. So in this case, I'm going to have 3 plus negative 5. When adding a negative number, that's the same as just subtracting that number. So 3 subtract 5 gives us negative 2. As I must get my answer in standard form, I know the number at the front must be between 1 and less than 10. As 24 is too big, I can rewrite 24 as being 2.4 multiplied by 10. And 10 is the same as 10 to the power 1. And we've still got times 10 to the power negative 2. Leaving the 2.4 alone and simplifying my powers of 10. I know my laws of indices, we're multiplying and we've got the same base. We keep the base the same and multiplying means we add the powers. Well, 1 add negative 2. Again, if you're adding a negative number, that's the same as subtracting a number. So 1 subtract 2 gives us negative 1. Question 5. Here is a regular hexagon and a regular pentagon, and we're asked to work out the size of angle marked X. You must show all your working. Regular means all sides and all angles are equal. A hexagon has 6 sides, so I can put a line each side to indicate they're all the same. I also have a regular pentagon, so again for my pentagon, I know all sides and all angles are the same. As the regular hexagon and the regular pentagon share this side in common, therefore I also know all these sides are exactly the same. Taking each polygon separately, I show the sum of the exterior angles, where exterior has the letter E for exit, the angle on the outside. The sum of the exterior angles of any polygon always sums to 360. As it's regular, I know all the exterior angles are the same. Hence, I should know to work out one exterior angle, it's simply going to be 360 degrees divided by n, where n is the number of sides. Taking my polygon here on the left, my hexagon, therefore the exterior angle of a regular hexagon is going to be 360 degrees divided by the number of sides. Well, the hexagon has 6 sides, and 360 divided by 6 gives us 6 degrees. So each of my exterior angles equals 60 degrees. I should know that one exterior plus one interior for inside, always makes a straight line. So if I've got the exterior angle, to work out the interior angle, I can just do 180, subtract the exterior angle. Hence, in this case here, my interior angle is going to be 180 degrees, subtract my exterior. So in this case, 180, subtract my 6 degrees, my exterior. And 180 take away 60 gives us 120. Repeating this process now for the regular pentagon. Again, I know regular means all sides and all angles are the same. I know a pentagon has 5 sides. As I know the sum of the exterior angles of a pentagon is 360. To work out the size of one exterior angle is going to be 360 divided by the number of sides. Well, 360 divided by 5, that will give us 72 degrees. So each exterior angle is 72. That will be the angle on the outside. To work out the interior angle of my regular pentagon, I know one interior plus one exterior always make a straight line, i.e. 180 degrees. As I know my exterior angle is 72, therefore I can just do 180 degrees, subtract my exterior angle, which is 72, and 180 subtract 72, therefore give me an interior angle of 108 degrees. As I want to work out the size of angle X, on the left-hand side here, I have a regular hexagon. As I know all the interior angles are the same, I worked out earlier that the interior angle of a regular hexagon is 120, hence that will be also 120 degrees. On the right-hand side here, I have a regular pentagon. And again, I worked out earlier that the size of an interior angle of a regular pentagon is 108 degrees. As it's regular, it means all the angles are the same. So this is also going to be 108 degrees. As I want to work out the size of angle X, I know angles around a point add up to 360 degrees. Hence, I can add up my 120 and 108 degrees and subtract from 360. Well, 120 plus 108, that gives us 228. I know angles around a point add up to 360. Hence, 360 subtract 228. And that gives us a final answer, my value for X, that comes out to be 132 degrees. Question 6. Complete the table of values.